I'm actually going to give you guys a little excerpt from our pitch deck. Pitch decks are so I live in San Francisco. We're based out of there. We're a small startup. The goal here, so we named it PipelineAI because eventually we want to be the entire pipeline, but because of our size, we actually chose to focus on the post-training pipeline. And this is a very under-engineered part of your ML pipeline. So there's hundreds, thousands of companies, a ton of people out here in the expo area that are focused on model training and offline hyperparameter tuning. And this is where you're trying different parameters, different learning rates, different tree depths for your decision trees, and seeing which models fit the best, which hyperparameters can get you the best fit for your data. And so that's great. One thing at Netflix that we always from scratch, we always felt that production was the best place to actually validate these models. So instead of just saying that this model is better than this other variant because of its offline properties, we actually don't consider this model to be the best model until it's in production. So how do you do this? So you need a safe way to get these models in production, shadow traffic to them. There's a lot of infrastructure, right? We all know that. It's not just the actual modeling. So with Pipeline, you could actually get these models into production quickly and compare them side by side. And it's safe. You're not going to take down production. You can then start to compare these predictive performance, the system performance, latency. So the main tenet is offline, you're always trying to optimize for accuracy, whereas online, there's a lot of other things. There's applications need these predictions under 10 milliseconds, that kind of thing. We've been working with Halliburton. The other part of the week this week I was there. So Halliburton has essentially a vertical cloud that they're building. And if you're familiar with services like SageMaker from Amazon, there's a bunch of announcements at the reInvent conference this week in Vegas. So we're basically SageMaker, but we're multi-cloud and kind of specific to these vertical industries. So we've been working with electronics and IoT. We're very streaming based, very real time. So I pretty much already said this already, but we're more for the online model training, so keeping these models up to date. We can't always say that that's the best for your particular situation, but people seem to always want it. So this is actually training once, getting the model in, and then sort of incrementally keeping this model up to date, which is good and bad, and I'm sure you all understand things that could happen online. Different trends that you pick up. This is something Netflix dealt with quite a bit. You don't want to, the big event for Netflix would be post-Oscars. So right after the Oscars, there'd be this huge spike. And if we based all of our models on the 6 hours after the Oscars, we would think there's only 10 movies that are actually being watched by people, which is not true, obviously. So the ability to experiment real time. There's also this, these new online hyperparameters that I'm sure, lots of you might have read about. These are more ML 3.0 focused, right? So ML 1.0 would be what I studied, MATLAB, and some of the stuff back in college. ML 2.0 would be scikit, and possibly R. Maybe R is 1.0 as well. But ML 3.0 is very, very production focused. This is TensorFlow, Keras. This is MXNet. These are frameworks that are meant to be put into production very low latency. And there's a lot of these post-training things you can do. So once the model's been trained and it's been optimized for accuracy, there's now little things you can do to the model to make it faster during prediction time. And that's fusing together layers, right? Because there's things when you tell these frameworks that you're now ready to actually put this in production, and there's no more training that's going to happen, or maybe minimal sort of incremental training. There's lots of things you can do to these networks to shrink them down, to make the math faster. You can quantize what, if you train at 32-bit to get very high accuracy, you would then quantize and slim it down to maybe 16-bit. So now all of the weights that you've learned have been shrunk to 16-bit, or even in TensorFlow, there's this new data type called bfloat16, which is not quantized. It's literally just chopped in half. It's not IEEE standard, but it's something worth trying out. So these are all the little switches through our UI, through our REST API, that you can take your model that's been trained, put it into our system. We'll generate 5 or 6 different variations that we've seen over time work for your particular workloads. So the other guys, this is of course competitive stuff because it's a pitch deck, but most people focus on building blocks, either relying on open source and cobbling those together, sort of bespoke systems, right? Like you're all familiar with the ops guy next to you that's spinning up a Flask app and putting a scikit-learn model behind it, and then that works, but you have no insight, you have no ability to measure and tune and optimize. Yeah, so we actually registered no Flask app, .com recently, and it goes straight to PipelineAI, which is kind of funny. Some quick notes here. We do have an open source. We started off open source. We have about, I think, close to 400 stars now, which is good traction. We also have this community edition where you can touch and feel, and that's what I'll be demoing here if I have time. And the typical personas is the bottom right. So we're most proud of dealing with the application developer side, because that means that our message is coming across, that this is meant for application like machine learning. Yeah, where's my timer? Okay. Is that 3 minutes left or 3 minutes in? Okay. What we're finding, there's kind of crazy metrics out here, but less than 5% of all models go into production, 1 to 3 months to test a new variant, a new offline hyperparameter configuration, but really we want to be testing online as well, as fast as possible. So some of these, we actually have a blog post coming out next week. We waited till next week because there's a lot of conferences this week that will highlight. We had a huge response to a sort of online machine learning survey that we posted last month. And there's a lot of, where do we want to deploy these things? What are we trying to achieve? Bias detection, model decay over time. And yeah, so that's business model. I think that's that. We could take some questions, or I can quickly show you guys. So here's an example. We actually have implemented MNIST in 7 different ways with 7 different frameworks. And then, yes, out of that, so we've trained these models. We brought them into our system. We've then deployed and optimized and generated about, I think, 12 different variants. And now we're actually running this load test, and we can run it across all clouds. So kind of the marquee demo here is that we deploy these Docker images, right? So they end up being Docker images that wrap the model and give life to these models. These models now become executables, basically. And so we can actually find the cheapest or the most efficient, either fastest or cheapest cost per prediction spread across all the different clouds. And so throughout the day, if you lose your cheaper spot instances with Amazon, for example, we could actually shift traffic over to Azure or to Google Cloud, depending on current price per prediction. So that stuff's pretty fun. We also have ways to introduce, so because we're the runtime for all these predictions, we could start to add in new value. And the big push these days is explainability. There was a talk yesterday that brought up the tree, Shapley, and Lime. And so we support both of those as part of the runtime. Yeah.